students, today's topic Unit 4 Multiple Integrals. The concept is change of order of integration. Contents are objective and outcome, change of order of integration in double integrals, working rule, and applications. Objective and outcome. The objective is change of order of integration in double integral, and outcome will be students get to understand the concept of evaluating the double integrals when changing the order of integration. Change of order of integration, working rule. If the limits of x and y are constant, then the double integral can be integrated in either order. If all the limits of double integral are constants, then the order of an integration is immaterial provided the limits are to be changed accordingly. That is, all the limits are constants. Then we have to integrate first with respect to x and then y, or first with respect to y and then x. In both cases, we will get the same result. So that is, when the limits of double integral are constant, then the order of an integration is immaterial, provided the limits are to be changed accordingly. If the limits of y are functions of x, then the new limits of x in functions of y are to be determined. That means if the limits of double integral are variable limits, suppose y limits are functions of x, that is y limits are in terms of x, we have to change the order. For this, we have to change the limits also. That means we have to convert x limits in terms of y is to be determined. So once again, if all the limits are constants, then the order of an integration is immaterial. We have to apply integration with respect to any order. That means first with respect to y and then x, and first with respect to x and then y. In case of constant limits, suppose in case of variable limits, that is y limits are in terms of x and x limits are in terms of y, then we have to change the limits also. For this, we have to draw the rough sketch of the region. That is, the best method is by geometrical consideration. That means we have to draw the rough sketch of the region and changing the limits accordingly by using the old strip and new strip. Thus, in several problems, the evaluation of double integral becomes easier with the change of order of integration, which of course changing the limits also. So in double integral, some of the problems cannot be determined easily. If we change the order of an integration, then we can simply solve the given double integration sum. Of course, we have to change the limits also. Remark, if y depends upon x and we want to x depends upon y, to change the limits we have to convert x is depends upon y, that is x equal to f of y. Then we have to construct a strip which is parallel to x axis. So once again, y depends upon x, but we want to x depends upon y, that is x equal to f of y. Then we have to construct a strip which is parallel to x axis. That is, the new strip is drawn parallel to x axis. Once again, if we know the working rule, then it is easy to evaluate the given sums. If all the limits of a double integral are constant, then the change of order of integration requires the changing the limits also. Simply we can solve the problem by changing the limits accordingly. Or if we want to integrate first with respect to x and then y, first with respect to y and then x, in both cases we'll get the same result in case of limits or constants. If the limits are variable limits, that is y limits are in terms of x, then we have to convert x limits are in terms of y. Then we have to change the limits accordingly. For this, we have to consider geometrical consideration. That means we have to take a old strip in the given region and then we have to take the new strip to change the limits accordingly. For this, we have to draw the rough sketch of the region. Evaluate double integral by changing the order of integration. The problem is we have to evaluate this double integral by changing the order of integration. So it is the rough sketch of the region according to given problem. Here y limits are 0 to root of 1 minus x square. Y varies as y equal to 0, y equal to root of 1 minus x square. These are the inner integral limits related to y, because y limits are in terms of x, and outer integral limits are x limits, that is x limits are 0 to 1. So here y varies as 0 to root of 1 minus x square, that is y equal to 0, y equal to root of 1 minus x square. Y equal to 0 means x axis, y equal to root of 1 minus x square, that means squaring on both sides we will have y square is 1 minus x square, which implies that x square plus y square is 1, which represents the circle having center at origin and radius 1 units. So which represents the circle having center at origin and having radius 1 units. So it is the unit radius circle. So it is the unit radius circle. So the rough sketch is region taken with respect to y limits here, that is y equal to 0 means x axis and y equal to root of 1 minus x square means circle having center at origin and radius 1 units. And we will have x limits are x equal to 0 and x equal to 1. X equal to 0, which means that y axis. X equal to 1, that means x equal to 1 line is parallel to y axis. X equal to 1 line is parallel to y axis, and the intersection point with the circle x axis is 1 0, so that the line x equal to 1 is passes through the point 1 comma 0, and also the line x equal to 1 line is the tangent line to the circle. X equal to 1 line is a tangent line to the circle. So it is the rough sketch of the region according to the given region. The region is taken with respect to the given limits. Once again, y limits are y equal to 0, y equal to root of 1 minus x square, y equal to 0 means x axis, and y equal to root of 1 minus x square means circle, x equal to 0 means y axis, x equal to 1 line is parallel to y axis. In the above integral, y on vertical strip, so that is vertical strip is old strip, because here y varies as 0 to root of 1 minus x square. So y varies as 0 to root of 1 minus x square is the strip considered in only in first quadrant. So y varies as function of x, and then the strip slides between x equal to 0 to x equal to 1. So since here x varies as 0 to 1, so that we have to consider the dotted area which is in closed area, closed region, and we have to consider the dotted area only in first quadrant, because x varies as 0 to 1 and y varies as 0 to root of 1 minus x square. The lower part of the strip touches to the x-axis, so y equal to 0. Upper part of the strip, old strip, PQ is old strip. Upper part of the strip touches to the curve, that is a circle, where y is root of 1 minus x square. But we have to change the order. But change of order of integration requires changing the limits also. For this, we have to draw the rough sketch of the region and changing the limits accordingly. For this, we have to consider a new strip, that is P dash Q dash is the new strip. New strip is drawn opposite to the old strip, that is the old strip PQ is vertical but new strip considered as horizontal, that is parallel to x-axis. The new strip, with respect to new strip we have to consider the new limits. Whenever we change the limits, the order can be changed. Here y equal to 0 is the x-axis, y equal to root of 1 minus x square is the circle. In the changed order, the strip P dash Q dash is the new strip. P dash is resting on the curve x equal to 0. X equal to 0 means y-axis, and Q dash on the circle. Q dash is resting on circle. X equal to root of 1 minus y square, and finally the strip P dash Q dash sliding between y equal to 0 and y equal to 1. Y equal to 0 and y equal to 1. The circle intersect y-axis at the point 0, 1 is the intersecting point to the y-axis of the circle. The circle equation is x square plus y square equal to 1. So here the new limits are obtained according to new strip. We have to consider the new limits. So P dash Q dash is the new strip. With respect to new strip, here y limits are obtained. The y limits are y equal to 0 to y equal to 1 are the new limits for y, and x limits are x varies as 0 because y axis equation is x equal to 0, and the strip resting on q dash on circle, here x is root of 1 minus y square, thus x limits are obtained. X limits must and should be function of y, and y limits must and should be constants. So whenever we found the limits, then the problem can be easily solved. So it is the problem by taking the new limits. So new limits are x varies as 0 to root of 1 minus s y square, and y limits as 0 to 1. So clearly here we changed the order. So in given problem the order is dy dx, but we have changed here order as dx dy, and we have changed the limits also. So here we have to integrate first with respect to x and then y. But while integrating with respect to x, we have to keep y terms as fixed. That is, y terms are treated as constant, so that y square is taken out to the inner integral. Now, what is the integration for 1 with respect to x? X limits are 0 to root of 1 minus y square. So x limits 0 to root of 1 minus y square. Root of 1 minus y square and lower limit as 0. So the integration becomes integral 0 to 1 y square into root of 1 minus y square means 1 minus y square whole to the power of 1 by 2 into dy. Now clearly double integration sum is now becomes a single integration. Now we have to solve this single integration. This integral can be solved by using substitution method. For this we have to replace y as sin theta, y equal to sin theta, and dy will be cos theta d theta, that is the derivative of y with respect to theta, and theta varies as 0 to pi by 2, because when y equal to 0 sin theta is 0, which implies theta equal to 0. When y equal to 1 sin theta is 1, but 1 can be written as sin pi by 2. But what is the value of sin pi by 2? 1. So applying sin inverse on both sides, so that we will have theta equal to pi by 2. These are the new limits related to theta. These are the limits related to y. Now substituting these values, the integral becomes, what is y? Y is a sine theta. Y square means sine square theta. Sine square theta. 1 minus y square means 1 minus sine square theta. That is a cos square theta whole to the power of 1 by 2 means cos theta. But already we have dy. But what is a dy? Cos theta d theta. Cos theta into cos theta. Cos square theta into d theta. Now this integral can be solved by using the known formula. Formula is integral 0 to pi by 2 sin power p theta into cos power q theta d theta is p minus 1 into p minus 3 and so on, q minus 1 q minus 3 and so on, whole by p plus q into p plus q minus 2 into pi by 2 only when both pq's are positive integers. Here small q is missing, just note down. Sin power p theta into cos power q theta. Cos power q theta into d theta. So it is the formula. Just we have to replace p equal to 2 and q equal to 2. In this, we will get the result as pi by 16. So easily we can obtain the required value of the given integral by changing the order of integration. Just by changing the order of integration requires changing the limits also. This can be done by drawing the rough sketch of the region and changing the limits accordingly. Rough sketch must and should be we have to draw. We have to change the new limits. For this we have to take the new strip in the same region where the old strip lies. In the same region we have to take the new strip. According to new strip we have to consider new limits. Then only we can change the order and we can solve the given sum easily. So it is the process. Problem: change the order of integration in the following integral and evaluate. The problem is integral 0 to 4a integral x square by 4a to 2 root ax dy dx. So here inner integral limits are y limits in terms of x and x limits are 0 to 4a constant limits. Now first we have to draw the rough sketch of the region. It is the rough sketch of the region. So clearly we will see here y equal to x square by 4a is the lower limit. Y equal to x square by 4a means x square is 4ay. So x square is 4ay is the parabola which passing through origin and symmetrical about y axis. So x square equal to 4ay we have drawn by using the lower limit. Now upper limit of y is y equal to 2 root ax. 2 root ax means now squaring on both sides y square is 4ax. So y square is 4ax. It is also passing through origin and intersecting the parabola x square equal to 4ay at the point 4a. So it is the intersection point. These two parabolas are intersecting at 2 points. One is origin 0, 0 and another point is 4a, which is obtained by just solving these two equations. These two equations are solved by using substitutions. So we will get the intersecting point as 4a. Now we will have x limits. The x limit is x equal to 0. X equal to 0 means y axis and x equal to 4a means the ordinate line is parallel to y axis and which passing through the point 4a because here x coordinate is 4a. So the line x equal to 4a must and should be passing through the point 4a comma 4a. So it is the line x equal to 4a. So it is the rough sketch region about which is drawn about taking the limits of the given double integral. Once again, y limits are variable limits here in terms of x. Y equal to x square by 4a means x square equal to 4ay. Parabola symmetric about y axis and passing through origin. Y equal to 2 root ax means y square equal to 4ax, which is also parabola symmetrical about x-axis and passing through the origin. Intersection with x square equal to 4ay is 4a comma 4a. And these limits x varies as 0 to 4a. X equal to 0 means y-axis and x equal to 4a means the line which is parallel to y-axis. So it is the rough sketch region which is taken by the limits of the given double integral. And the old strip lies, that is old strip means pq is the old strip which lies in this closed region, that is the dotted region. It is the old strip because here y varies as x square by 4a to 2 root ax, that is the parabola x square equal to 4a by 2, the parabola y square equal to 4ax. So that we have to draw the rough sketch in this closed region, and clearly in this closed region x varies as 0 to 4a because one of the ordinate is 0, 0 and another ordinate is 4a comma 0 as a vertex with x-axis because x equal to 4a line which passing through the point 4a comma 0. So x limits as 0 to 4a. the limits of y equal to x square by 4a and y equal to 2 root ax and x equal to 0 and x equal to 4a. From the parabola y square equal to 4ax, that is x equal to y square by 4a, and from the parabola x square equal to 4ay, that is x equal to 2 root ay, that is x varies from y square by 4a and to 2 root ay. So according to new strip, that is the new strip horizontal to the x-axis, that is the new strip left part is touches to the parabola y square equal to 4ax. In this, x is y square by 4a. Thus, the lower limit of x is obtained, and the rest q dash is on x square equal to 4ay. Here x is 2 root ay. Thus the upper limit of x is obtained. X varies as y square by 4a to 2 root ay. These are the limits of new limits. That is x varies as y square by 4a to 2 root ay. And y limits. So clearly here ordinates are 0 0 and 0 4a with respect to y axis. Thus the new limits are obtained. X limits as y square by 4a to 2 root ay as x limits, and y limits are 0 to 4a. So using these limits, now we can solve the given sum. It is the given sum 0 to 4a x square by 4a to 2 root ax dy dx. Now by changing the order and limits, the sum becomes 0 to 4a as y limits and y square by 4a to 2 root ay as x limits. So clearly we can observe here dy dx order is now becomes dx dy, and the limits are also changed here. Now we have to integrate with respect to x as inner integral and then outer integral with respect to y. But what is the integration 1 with respect to x? X. Substituting upper limit as 2 root ay and then lower limit as y square by 4a. Now clearly the double integration sum is now becomes a single integration. Now we have to solve this a single integration. Now integrating with respect to y. 2 root a is constant and root y. Root y means y power 1 by 2. Y power 1 by 2 integration is y power 1 by 2 plus 1 by 1 by 2 plus 1. That is y power 3 by 2 by 3 by 2. Here 1 by 4a is constant, y square integration is y cube by 3. So already we have 1 by 4a, that is 3 into 4a is 12a. Thus we will have 5 cube by 12a. Now substituting upper limit as a 4a and lower limit as 0. While substituting lower limit as a 0, the total value becomes 0. Now substituting upper limit 4a in place of y and simplifying, we will get the result is 32a square by 3 minus 16a square by 3, that is 16a square by 3 is the required result of the given double integral. So easily we can obtain. Another problem is change the order of integration in the following integral and evaluate. The problem is integral 0 to 1 integral x square to 2 minus x xy dy dx. Here double integral problem can be evaluated by the use of change of order of integration. Here the limits of y are x square to 2 minus x. These are the y limits, and 0 to 1 are x limits. First we have to draw the rough sketch of the region. Y varies as x square to 2 minus x. That is y equal to x square and y equal to 2 minus x. The rough sketch of the region is like this. Y equal to x square means x equal to root y. It is the parabola passing through origin and symmetrical about y-axis. So y equal to x square is parabola, nothing but x equal to root y, passing through origin and symmetrical about y-axis, and y equal to 2 minus x. So y equal to 2 minus x or x equal to 2 minus y means line which passing through the point 0 2 and the point 2 0 with x-axis. So x equal to 2 minus y is a line which passes through the points 0 2 with y-axis and 2 0 with x-axis. So it is the rough sketch of the region. And x equal to 0. X equal to 0 means y axis. X equal to one line. X equal to one line is a line parallel to y-axis and passing through the point 1, 0 with x-axis, 1, 0 with x-axis, and the parabola and line, the point is 1, 1. So these are the intersection point with x equal to 1 line, x equal to 1 line which meets the curve and the line at the point 1, 1, and with the y-axis is 1, 0. 1, 0. So it is the rough sketch of the region. So once again, y equal to x square means parabola, y equal to 2 minus x means a line which passing through the points 0, 2 with y-axis, 2, 0 with x-axis, and intersection point is 1, 1, and x equal to 0 means y-axis, x equal to 1 line means parallel to y-axis, intersecting at 2 points. One point is 1, 1, and another point at x-axis is 1, 0. So it is about rough sketch of the region. So y limits as x square and y equal to 2 minus x is 0 and x equal to 1. The point of intersection of the parabola y equal to x square and the line y equal to 2 minus x is b, 1, 1. We have taken a step parallel to x-axis in the regions OBC and the second step in the region ABC. So OBC is the first region and the another region is ABC. The limits of x in area OBC are 0 to root y because the step, new step touches to the y-axis so that x equal to 0. The new step touches to the curve so that x equal to root y. Then next second step, for the next step, that is ABC region, x limits as 0 to 2 minus y. 0 to 2 minus y according to new strip in the region ABC. X limits as 0 to 2 minus y. Thus, x limits are obtained. The new limits are obtained. The old strip is drawn parallel to y-axis. It is not shown in the figure. So we have to consider only this region because the curve y equal to x square and y equal to 2 minus x equal to 0, that means y-axis, and x equal to 1 line which is parallel to y-axis. These are all meet in this region so that the old strip is drawn parallel to y-axis, which is not shown in the figure, but for we have to take the new limits. For these new limits, we have to divide the total region into two parts with respect to a line. The line is CB line here, that is y equal to 1 line which is parallel to x-axis. According to new strips, the new limits are these, that is in the region OBC, x limits as 0 to root y, and in the region ABC, the new limits are 0 to 2 minus y. Now using new limits, the given sum, it is the new sum, given sum. Now by the changing the order of integration, that is dx dy. So double integral are splitted here with respect to OBC region and ABC region. OBC region and ABC region. The double integration given sum is splitted using the new limits. Now applying integration with respect to y and then x. So problem is easily evaluated. X integration is x square by 2, limits 0 to root y. X integration is x square by 2, limits 0 to 2 minus y. Substituting upper limits and lower limits. Clearly, the double integration's sum is now becomes single integration. Now y square integration is y cube by 3 and y into 2 minus y whole square is splitted. Substituting upper limit as 1 and lower limit as 0 in first term, and we have to integrate this. 4y integration is a 2y square, 4y square integration is a 4y cube by 3, y cube integration is y power 4 by 4. Limits upper limit as 2 and lower limit as 1. Substituting upper limit minus lower limit and then simplifying, 1 by 6 plus 5 by 24, that is a 9 by 24. That means using 3 table 3 by 8. So it is the required value. Another problem, change the order of integration in the following integral and evaluate. The problem is 0 to 3, 1 to root of 4 minus y, x plus y, dx dy. So here x limits are in terms of y, that is x varies as 1 to root of 4 minus y, x equal to 1 line means parallel to y axis, x equal to root of 4 minus y means squaring on both sides, we will have a parabola. Y equal to 0 means x-axis, and y equal to 3 means a line which is a parallel to x-axis. So once again, x equal to 1 means the straight line parallel to y-axis, x equal to root of 4 minus y, which means a parabola, and y equal to 0 means x-axis, and y equal to 3 means the line parallel to x-axis. So it is the rough sketch of the region. So it is the region, rough sketch of the region. So once again, look at the figure. X limits as 1 to root of 4 minus y. X equal to 1 line means parallel to y-axis. So it is x equal to 1 line. Next, x equal to root of 4 minus y line curve means parabola. It is the parabola which meets x-axis at 2, 0. And y equal to 0 means x-axis. So it is y equal to 0, that means x-axis. And y equal to 3, y equal to 3 line means parallel to x-axis. So it is the region according to the given limits. So clearly in the given form integral x changes as a function of y, that is x changes as function of y, and y is an independent variable which changes from 0 to 3. Now by changing the order of integration, for changing the order of integration, we need to convert the horizontal strip, that is PQ strip, to vertical strip, that is P dash Q dash is the new strip which y changes as a function of x. Y changes as function of x, and it slides the values for x equal to 1 to x equal to 2 as shown in the figure. So it is the figure. Here old strip is PQ and the new strip is P dash Q dash, which is considered in the same dotted region, same closure region. X varies as here 1 to 2. So given sum, and now changing the order of integration, changing the limits here, that is x varies as here 1 to 2 and y varies as here 0 to curve. What is curve here? The curve is y equal to 4 minus x square is the parabola. So y limits are 0 to 4 minus x square are the y limits. So y limits is 0 to 4 minus x square, and x limits as 1 to 2. So here AB is the region. In this region 1, 0, 2, 0 are the alternates. X varies as 1 to 2. Now applying integration with respect to y and then x. So substituting while integrating with respect to y, keep x terms as constant. X is constant. One integration is a y, and y integration is a y square by 2. Substituting upper limit as 4 minus x square and lower limit as 0. So on simplifying, so clearly the double integration sum is now becomes single integration. Now evaluating the single integration, integrating and then substituting upper limit as 2 and lower limit as 1. Upper limit minus lower limit, upper limit minus lower limit. In each term we have substituted. On simplifying, we will get the result is 241 by 60. So it is the required value of the given double integral. So easily we have obtained. Just we have to draw the rough sketch of the region. Just we have to take the rough sketch of the region, and we have to take the old strip, that is a PQ strip, in the closed region where the curves and lines are meet in the given region according to the old limits. To take the new limits, we have to draw the new strip, that is a P dash Q dash, in the same closed region where the old strip has drawn. In the same region we have to take the new strip. We have to change the limits and we have to apply the integration. The double integration sum has changes to single integration, and evaluating the single integration and solving, we will get the required constant value. So easily we can change the order of integration of the double integral. It is about the concept of change of order of integration in double integrals. If any queries or any doubts, please contact me. Thank you.